All right, so the whole thing about Lab 11 is you guys are focusing on titrations, and from titrations we can find the unknown concentration of something that you're working with, which is super important when you say are taking a sample of something and you want to know, is it acidic, is it basic? These are ways to do that. So hopefully this lab is going to really cement in those things. We're going to go through first the actual lab, what we're doing, and then we're going to go through essentially some of the calculations, I think, and some of the theory to make sure that we understand what's going on. All right, so the first thing you're going to do is you're going to make an unknown. I found that I troubleshot, I should say, that if you take the HCl first, it really doesn't want to create any unknowns for you. So you're going to go to unknowns, create unknown, acid base. You're going to click on hydrochloric acid, and anywhere between 0.1 and 0.12 is fine. Hit create, and you're going to go back. Oh, and then you're going to click it, and it'll magically appear here. Thank you, invisible stockroom person. Then you go to the stockroom. You're going to go to base, and you open up your base. Casey, who wrote the lab manual, says to bring them here. I trust everything she says because this thing is crazy temperamental. So if she tells me to put them on my lab bench, you best believe I'm putting them on my lab bench. So I'm going to go back to live data. The next thing we're going to do is pull out some beakers. Maybe not. It's going to go all the way back there for some reason. Bring them up here, and I'm going to close that. And then I'm going to pull out this pipette. I'm going to be honest. The thing that took the longest for me to make this video was the fact that I couldn't get this pipette to work. So I'm going to show you a way else to do that should your pipette not work either. The next thing we're going to do is I took the sodium hydroxide, I hover it, and I just fill my little burette up. It magically puts itself to 0.00. If you want to be fancy and put it at 0.01, that's up to you, but just know that burettes are always going to have up to 2 decimal places for the of accuracy. Same thing with my pipette. So I'm going to take this, I'm going to pour that into my beaker. She says about 3/4 full. I'm going to be honest, I do half full because I get scared it's going to spill. A common theme that I've found when going through these labs. I then hit the little bulb. And yeah, it's done this. It's an error. It doesn't work now. And instead of clearing this bench and doing a bunch of stuff, if it works for you, wonderful. What you're going to do is you're going to tip this over here, you're going to pull this over here, and you're going to hit the bulb again, and it's going to spew that 25.00 milliliters in there. But for those of us, like myself, who've had this issue, I took this actually and I put it over my 25 milliliter volumetric, and eventually it will take. Oh, just kidding. It did not. There we go. Took that, and then I tipped it here. We just wait for it to decide that it's okay. There we go. Okay. So now I've got 25.00 mils in here, and I've got 50 milliliters of sodium hydroxide, because remember, we read this thing upside down, which for right now is totally easy. Later, it's totally not, so we'll go through that. And then I want to add a little bit of indicator, so I'm going to turn this little guy on. To add the indicator, I have found that this needs to be on. Sometimes it doesn't, but this is for complete accuracy. And for activity 1, we'll be using phenolphthalein. Phenolphthalein basically is clear in acidic concentrations, and then it becomes pink and or red in basic concentrations. So I'm going to take the dropper, and I have found that you have to find a sweet spot. Once I find it, you will know. There. And then essentially I have dropped in phenolphthalein. I'm going to release, and it goes back to its little thing. Then what I'm going to do is I'm just going to show you a scout titration to not waste your time. If you want to do a real titration, what you're going to do is kind of what I do. So I just pull this close. So for your scout, you're going to pull it down, and you really don't care if it turns. Now, if you want to be fancy, you can do a careful one first, and then just do 2 careful ones, and just pretend your scout wasn't that crazy. Me, because I've done this experiment before in real life, I kind of know that around 20 things start getting a little crazy. Okay, so I'm going to say around 24 is when it completely changed for my scout. And so next time when you do your careful one, what I would do is add up to around 22 and then start slowing that down, right? So just to show, like, you just kind of make little drops this way, okay? It's all about the little touch that makes it perfect. So yeah, that's basically how this lab works. It's pretty straightforward. Again, if the pipette is being a jerk to you like it was to me, you can always use the graduated cylinders. I think that's a nice little backup trick. Remember to load the unknown first before loading in your HCl, because if you pick it from the stock room, then you're going to have to clear your bench and do everything over again. Yep, so that should be it for the BeyondLabz section. And now I'm just going to go a little bit into the, oh, that's my face, not what I wanted. Going to go just a little bit into some of the calculation stuff. So I've made up a calculation to help. Hopefully that's going to overall give you a bit of an idea here. So the first thing is one of them says that you're going to be using 12.06 milliliters of a certain concentration of sodium hydroxide. And so what you're going to need to do is neutralize that with some unknown molarity. So in this case, it says I've neutralized it with 25 milliliters of hydrochloric acid. So what I'm going to do is I need to remember to myself that molarity, that big M, equals moles per liter. And so when I have anything that's in mole per liter, I need to know that all of my volumes that are in milliliters are going to need to become liters. And so what I'm going to do is I'm first going to take this 12.06 milliliters and I'm going to convert that now into liters. So I'm going to multiply that by 1 liter divided by 1,000 milliliters, and by dividing it by that 1,000 milliliters, I'm going to get 0.01206 liters, and that 0.01206 liters is then going to be able to be multiplied by my molarity. So in this case 0.60, in this case 0.610 moles per 1 liter is going to equal, and so I just take out my calculator and I'm going to go and take these two and multiply them now by each other, because again, if we're kind of taking this as is, we're going to be canceling out all of these units. So I cancel out my milliliters, I'm canceling out my liters, and I'm going to end up with moles at the end of the day, right? Because I've got liters, that leads to here, and then I cancel out liters with my molarity. So then I'm going to pull out my calculator, and I'm going to do 0.01206 multiplied by 0.610, and I get, with sig figs, because we have 4 significant digits, is 7.357 e to the negative 3 moles, and that's of my sodium hydroxide solution. Okay, so that's how many moles of sodium hydroxide were used. Great. Now it asks me how many moles of HCl are in the neutralized solution. And so then I'm going to go actually back to my lab manual, and if I look in here, I'm going to find that that overall chemical equation. And when I look at this chemical equation, I can clearly see that sodium hydroxide and hydrochloric acid are in a 1-to-1 ratio. And what that means for us is really good, because it means that whatever number of moles of sodium hydroxide I have, it's going to be in a 1-to-1 of that with my HCl. And so if I have this many moles of sodium hydroxide, if I multiply that by 1 mole of HCl and divide by 1 mole, which is what that ratio lets us do, of NaOH, I now can say that I multiplied it by 1, and I'm going to get this many moles of HCl. How great is that? So now we've got that down. And then it's asking me, what is the concentration of that HCl solution? So that's, we have that number of moles in HCl. That's always going to be in there. I think this is something that can get really lost in translation, that when we add the sodium hydroxide to neutralize that HCl solution, sometimes people think that that means we're changing the molarity in terms of the moles that are going to be present in that solution, but that is not the case. We're actually just changing the concentration so that we neutralize those moles, and that's what's happened. And so these moles were present before and will be present after that. So if I take these moles and I put them here, remember, moles is per liter. And so that means that if I have this many moles, I just have to divide it by the liters of HCl. And in this case, I have 0.025 liters, right? Because I would technically have I'd have this many milliliters, and I'd multiply it by 1 liter divided by 1,000 milliliters. And that then would equal this many divided by 0.025 liters, which would then give me a concentration of 0.29 molarity of HCl. So there we go. So that's kind of how to do these calculations. That's why titrations are so cool, and that they can give us the unknown concentrations by simply finding that equivalence point. Speaking of equivalence points, so when we go into activity 2, it talks a lot about using different indicators. So we've done this, blah, blah, blah. So activity 2 is we're exploring pointiometric titrations, and so essentially basing it off of the curve. And so you're going to record a curve, and that's fine. The equivalence point is going to be found. So again, when you're in BeyondLabz, where's my titration? So you're essentially, oh, it went funny when I went small. Essentially, you're just going to record with the pH meter how that goes, and then you're going to graph how that went. And so when I look in here, you're going to get a graph like this. You're going to be titrating this with promescol green this time, so Pro B in here. Oh, I keep clicking on the wrong thing. This Pro P, promescol, or no, sorry, Pro G, promescol green. Or no, it is Pro P. Let me check. Let's see if no, it's Pro G, promescol green. That's a typo. Should be Pro G. And it's going to be yellow at low pH levels. So that means if I'm looking here, if I were to draw and give myself a highlighter, so it's going to be yellow in the low ones, and then it's saying basically it's going to turn, we'll do a bit more like this, like a blue up here. And so why it's called green is because in the middle, which you know yellow and that will make green, right? So in the middle it'll be that way. So you're basically going to use bromescol green to find that color change. So remember, you're going to be starting with acid and ending with a basic solution. Okay, so just to kind of look at that. And then you're just going to again record these same things and then do the same calculations that we did above. Okay, so I think that's all for Lab 11. If you have any other questions, please feel free to reach out to me by email and or come see your, you can also check in with the lab coordinator, Casey Wright, and she can also help especially if you're having BeyondLabz issues, because she can usually override them. I don't have the power to override BeyondLabz. But other than that, I think that's everything, and I hope you guys have a very helpful Lab 11 session. Great.